Alright, hey guys, this is 7.1, right triangle trigonometry. So starting off with this first section, 7.1, it's going to be a lot of review of Math 2 and Math 3, a lot of SOHCAHTOA, sine, cosine, tangent, and looking at the relationships in a right triangle. And then we'll go on to what if it's not a right triangle and how to find those relationships. So this top section here should be a review of just how to find those relationships. I'm not going to go through and read that to you, but opposite over hypotenuse, and we've been working with that in the last trig section as well. You should be familiar also obviously with Pythagorean theorem, a squared plus b squared equals c squared, and if this is a right triangle, that means the other angles add to 90 degrees because all angles add to 180 degrees. So all that means if I know one is a right angle, that the other two will add to 90. Alright, so one note here, if it says to solve the triangle, it doesn't say that in this one, but you'll see that terminology later on. It's asking you to find all the missing sides and all the missing angles. This one, it actually writes it out as find this. Lowercase usually denotes the sides, which are labeled here, and then this one, it uses Greek letters. So it gives you this angle, and then it says beta, which is across from B. So it's across from B, and then A and C for my sides. Okay, so we need to find all of these things. So the first thing I'm going to do is find beta. So I have a 90-degree angle and a 40-degree angle. So 90 minus 40 equals 50. So beta equals 50 degrees. Okay, so that's my missing angle there. Alright, so the next thing I can do is, I can do this a couple different ways. I'm going to go ahead and label this down here, as I'm going to have to use some of my trig that I know. So what I'm going to do is maybe, I'll use this 50 degrees. So cosine of 50 degrees equals adjacent, which is A, over, actually I don't want to do cosine. That's not going to help me. I want to do sine. Sine of 50. Okay, so opposite of 2. So sine of 50 degrees is opposite of, which is 2, over the hypotenuse, which is C. Okay, if I did cosine, that would give me 2 unknowns, so that wouldn't help me out very much. Alright, so make sure when you're doing these that your calculator should be in degree mode. Okay, or the calculator on your phone, whatever you're using there. So I'm just going to type in sine of 50 in my calculator. And then what I'm going to do is I'm going to multiply, so I get C times sine of 50 equals 2, and then divide both sides by sine of 50. And I would do that all before you type it in your calculator. So C ends up being 2.611. Okay. Now you have a couple of options here to find letter A or side A. Okay, so you can either use Pythagorean theorem because you have two sides, or you can use trig again. The only thing is if you use Pythagorean theorem is that make sure you use this exact side length. So I'm going to use Pythagorean theorem. So 2 squared plus a squared equals 2.611 squared. Just make sure you stored that value in your calculator. So 4 plus a squared equals 2.611 squared. And then take the square root. And you should get a equals 1.678. Okay, and a way to kind of check yourself on these is that it should go kind of in order. And what I mean by that is this is 90 degrees. And so I'm going to go ahead and label my side. So C is 2.611 and A we said is 1.678. So the biggest angle should be across from the biggest side. Okay, that checks out. And then the next biggest angle, which was 50, is the next biggest side. And then the smallest angle, which is 40, is across from the smallest side. So it should go in order there. And that's a way, obviously you don't know the exact numbers, but if you have a super big angle across from the smallest side, that's a way that you can check yourself that you know something went wrong. Alright, so next one, we have this picture here and we want to find, this time we have 2 missing angles and 1 missing side. I'm going to go ahead and find my hypotenuse here first. So 2 squared plus 3 squared equals c squared. So 4 plus 9 equals c squared. C equals the square root of 13. And when I type that in my calculator, I get 3.606. Okay. And notice that's going to be your biggest angle, which that's your 90-degree angle, and that's my biggest side. So I'm good so far. Alright, so next I'm going to maybe find beta. It doesn't matter. But let's go ahead and find that angle. So I'm going to I'll use the 2 and the 3 since those are exact values. So tangent of beta is opposite over adjacent. So 2 over 3. Okay, so tangent is 2 over 3. So in order to find the value, I'm going to have to do tangent inverse of 2/3 equals beta. And so again, on your calculator, it's just going to be second tangent is how you get that tangent inverse button. And so beta equals 33.69 degrees. And normally we'll go to 3 decimal places, but that's 690. Alright, and lastly, to get alpha, the easiest way to do this one would just be 90 minus beta, or 90 minus 33.69. So when I do that, I get 56.31 degrees. Oh, and I just kind of went over that. But there we go. And again, you can check yourself. So 56.31 is bigger. So 3 is across from that, and that's bigger than the 2. Okay, so it's just like a little bit of a self-check there to kind of make sure that you're on the right track. Okay, so that's a little bit of practice just with solving some right triangles. All right, so now we're going to get into some word problems here. Okay, I'm not going to read it to you, but I recommend you pause it and give yourself a chance to just read it for yourself. So a lot of these are nice that it gives you a picture. Sometimes it won't give you a picture and you'll need to be able to draw it for yourself. Okay, so you do need to be able to interpret what the question is asking though still. It says, what is the width of the river rounded to the nearest meter? So it talks about that the surveyor walks the distance of 200 meters, and that's labeled here. And then it talks about an angle of 90 degrees, and then this angle right here is 20 degrees, and we want the width of the river. So really it's asking for what is B right here. Okay, so basically this question is actually a little bit easier in the fact that I don't need to find everything, I just need to find the width of the river, which is B. So again, this one's nice that it's labeled for you. So this kind of goes back to Math 2 and Math 3. In terms of my 20 degrees, I have adjacent and I have opposite. So I'm going to use a tangent ratio. So tangent of 20 degrees equals B over 200. So B equals 200 times tangent of 20. So when you type that in your calculator, you get to 3 decimal places, 72.794, and we're talking about meters here. Okay, so that would be the width of the river. And it says to the nearest meter, so if it asks that, that'd be 73 meters. Okay. All right, next one. It says a straight trail from the Alpine Hotel, elevation of 8,000 feet. So the hotel is 8,000 feet above the ground. And then it goes up to 11,100 feet. The length of the trail, so the length of the trail here is 14,100 feet. And we want to find the angle of elevation here. Okay, now it's already done kind of the math of this, is saying to go from 8,000 to 11,100, this height right here is 3,100 feet. Okay, So we just really need to find the angle here. So I'm going to go ahead and just draw this triangle out over here. So we know that this is the length of the trail, which is 14,100. This height is 3,100, and we want to label or find that x. Okay, so we're finding an angle here. So I'm going to go ahead and label, in terms of my x, this is opposite, and this is my hypotenuse. So I'm going to use sine. So sine of x equals 3,100 over 14,100. So then to get the angle, I have to do the inverse. And when you type that in your calculator, you get right over here, 12.701 degrees. And you can see, obviously it's not drawn to scale, but you can see it's a very slight incline there. So 12.701 degrees. Alright, the last thing we're going to talk about in this section is angles of elevation and angles of depression. So elevation obviously is going up, and depression is the angle that's going down. Okay, so we're going to do two examples right here. Alright, so meteorologists, and this one we are going to have to label some things. So meteorologists find the height of a cloud using an instrument called a ceilometer. We're going to go with that. Alright, so it consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. So see this figure here. So with a base of 300 feet, so the base down here is 300 feet, was employed to find a height of the cloud cover. If the angle of elevation to the light detector was 75 degrees, okay, what is the height of the cloud cover? So that's what we want to find, okay, and round your answer to the nearest foot. Alright, so again, we're labeling the things that we know, and we want to find the height of the cloud cover. So here we have the angle, we want to find the height. So in terms of what I know, I have the angle, this is opposite and this is adjacent. So again, I'm going to use tangent of 75 equals h over 300. So my height is 300 times tangent of 75. When you type that in your calculator, you get 1,119.615 feet. I think this one does tell me to round to the nearest foot, so that would be 1120 feet. Okay. Alright, the last one. So it's talking about a building in Chicago, okay, and the Roman statue of Ceres, possibly, the Roman goddess of wheat. From street level, 2 observations are taken 400 feet from the center of the building. The angle of elevation to the base of the statue is found to be 55.1 degrees. The angle of elevation to the top of the statue is 56.5 degrees. And we want to find the height of the statue. Alright, so you can see that they've drawn these 2 triangles here to help us. Okay, so the first thing I want to do is to find this height to the base. So this is the one to the base of the statue. Okay. Alright, so let's go ahead and do this first. So we have the angle. This is very similarly set up to the previous question. So I have opposite and I have adjacent. So I'm going to use tangent again. So tangent of 55.1 equals b over 400. Multiply both sides by 400. So tangent of 55.1 times 400. So 573.387 feet. Okay, so that is the height to the base of the statue. So height to the base. Okay, now then we have the angle of elevation to the top of the statue. Okay, so we're going to do the same thing here. But instead of 55.1, we're going to use 56.5. And notice it's B prime just to differentiate that there. Okay, we're still 400 feet away. Everything has stayed the same here. So we multiply both sides by 400, so tangent of 56.5 times 400, and we get b prime equals 604.334. Okay, so that's the height to the top of the statue. And that got a little messed up, but it's okay. So my question is, or the question asks here, what is the height of the statue? So that's going to be from we have the to the top is 604, and then we have to the base is 573. So all we're going to do is we're going to subtract those two numbers. So 604.334 minus 573.387, and I'm going to use the exact numbers in my calculator just to make sure that there's no rounding errors. Okay, and that will give me the height. This is like my statue in between, from the base to the top. Okay, and so that gives me 30.948 feet. And it tells me to round to the nearest foot, so that's 31 feet. So there's a statue that's 31 feet tall. Okay. So this kind of gives you an introduction. There is one more page on bearing. We're not going to go over bearing. It's not as essential. Again, this is kind of the most essential part. So don't worry about that one last page on bearing angles. So this is kind of an introduction to right triangle trigonometry, angles of elevation, and angles of depression. Okay.